Yes, good morning students. So the next topic we are going to start with the binomial theorem. इधर हे करा क्या? कोपरा झाका था. Yes, so let us start with this topic, that is binomial theorem. So firstly we'll discuss about the theory part, okay, of this binomial theorem. So in that, as you learnt in the first year binomial theorem, only one theorem was very important in that, okay. So we need the statement of that theorem here, okay. So what is that statement of that theorem? X plus y to the power n, okay, can be written as what? nc0 x to the power n into y to the power 0 plus nc1 x to the power n minus 1 into y plus nc2 x to the power n minus 2 into y square plus so on plus ncn minus 1, okay, I think this is ncn x into y to the power n minus 1 plus ncn y to the power n, okay. So this is the statement, here. Okay, so in this statement what will happen? The first term, that is x, will go on what? See here, x to the power n, x to the power n minus 1, x to the power n minus 2. So it will go on decrease, whereas the second term y, it is y to the power n is there, y to the power 0, y to the power 1, y to the power 2, so on up to y to the power n. So the first term will go on decrease, whereas the second term will go on increase, okay. So this is the binomial expansion, okay, and this binomial expansion we can write in the form of summation. So x plus y to the power n is equals to summation of r is equals to 0 to n, okay, ncr x to the power n minus r into y to the power r, okay. So this is the expansion we have written in the form of what? Summation. Now suppose if you wanted to write for x minus y to the power n x minus y to the power n, same binomial theorem, what will happen? Same statement you will get it, only what? You have to give the alternative signs. See, I will make it here itself. If it is x minus y to the power n, then you have to give the alternative signs in the expansion. Means what? Start with plus, plus minus, here plus, this will become minus, plus minus, so on. It will be plus minus, and last one will be what? Last one will be here will get plus ncn into y to the power n into minus 1 to the power n, So this is for what? X minus y to the power n, Then similarly the summation, how we can write? R is equals to 0 to n minus 1 to the power n into, sorry, minus 1 to the power r into NCR x to the power n minus r into y to the power r, into y to the power r. Okay, so this is the summation result for x minus y to the power n. Okay, so this is the main what you can say concept in this binomial theorem, that is the statement of this binomial theorem. Okay, after that in the first year you have studied to find out the general term and the middle term, general term and the middle term. Okay, so what is general term now? I'll write it here. General term, yes, you know the formula for general term, that is TR plus 1. TR plus 1 is equals to what? NCR x to the power n minus r into y to the power r. So this is the general term for the expansion of what? X plus y to the power n. I will write it here, for x plus y to the power n. So for this expansion, the general term is what? TR plus 1 is equals to NCR x to the power n minus r into y to the power r. Okay, next another general term, TR plus 1 is equals to NCR into x to the power r, NCR into x to the power r. This is the general term for 1 plus x to the power n, 1 plus x to the power n. This is the general term. Okay, one more is there. Okay, I think I will write it here. TR plus 1 is equals to minus 1 to the power r into NCR into x to the power r. This is for 1 minus x to the power n, 1 minus x to the power n. Okay, so these are the three general terms I have given here. So first one is for x plus y to the power n, second one is for 1 plus x to the power n, third one is for 1 minus x to the power n. Okay, so we have seen the statement of the theorem and also we have seen the general term of that expansion. Okay, next concept. See, you have to remember these all the small things. Okay, now suppose in the binomial expansion of x plus y to the power n. Okay, we are going to see another result here. In the binomial expansion of x plus y to the power n, the pth term from the end is n minus 2 plus 2 term from the beginning. Okay, so what the result I have given here? In the expansion of this x plus y to the power n, okay, if you are finding the pth term, okay, then from the end or from the beginning it is what? N minus p plus 2th term, n minus p plus 2th term. That result you have to remember. Okay, after that we have the concept is independent and constant term. Okay, independent and constant term. Okay, so in the binomial expansion, what are the independent and constant term? What are the independent and constant term? Okay, so here in the binomial expansion, the term whose exponent, okay, or you can say the variable exponent is 0, and that term is called as independent term or constant term. Okay, now suppose I am having, this is nc1, and suppose x is the variable and its exponent is 0, then this nc1 is called as independent or constant. Okay, so in the binomial expansion, any term whose variable exponent is 0, then that term is called as what? Independent term or constant term. Okay, next, so for that there is a condition. For that independent term or the constant term, there is a condition. That condition is what? N minus r into power of x plus r into power of y, which is equals to what? 0. Because what we have said, the variable exponent is 0, so that so that power we have to equate here. Okay, but what is the condition? N minus r into power of x plus r into power of y, which is equals to 0. Important condition it is. Okay, after that, next we are going to see is number of terms in the expansion of a plus b plus c to the power n. So it is given by the formula n plus 1 into n plus 2 divided by 2. Okay, suppose you are having the term, that is, sorry, you are having the expression a plus b plus c to the power n, and if you are finding the number of terms present in this expansion, it can be found by formula what? N plus 1 into n plus 2 divided by 2. Suppose if you are finding the number of terms in the expansion of a plus b plus c plus d to the power n, a plus b plus c plus d to the power n, it is given by the formula n plus 1, n plus 2, n plus 3 upon 6. Okay, so these are the two formulas for what? Finding the number of terms in the expansion of what? A plus b plus c to the power n and a plus b plus c plus d to the power n. Okay, next. Okay, next we'll study about middle term. Okay, now see, to find the middle term, actually this concept also we have studied in the first year. Okay, now see, for simple examples. Okay, here how many numbers are there? 3 numbers are there, that is 1 2 3. 3 numbers are there. Okay, then I want the middle term of these 3 numbers. What you will do? Okay, what is the middle term of this? You will skip this, you will skip this. So 2 will be the middle term. 2 will be the middle term, correct? Now suppose I am having okay, so when you found this middle term, how many number of terms is present in this? Number of terms in this is 3. 1, 2, 3. 3 terms were present. Number of terms are 3, which is what? Odd. Which is what? Odd. When odd numbers of terms are present, you will get only one middle term. You will get only one middle term. Now see here. 1, 2, 3, 4, 5, 6. Here n is equals to how much? 6. How many number of terms are present in this? That is 6. So it is even or odd? It is even number of terms. Then how you will find the middle number of this or middle term of this? You have to skip these 2. You have to skip these 2. How many are left? 2 middle terms are left. So it is clear that. So when you are having odd number of terms, that when n is odd, you will get one middle term. When n is even, you will get 2 middle terms. When you will get 2 middle terms. But we have to see generally. We have to see generally. Okay. So see here. When n is even, when n is even, middle term, that is m is equals to, okay, n by 2 plus 1th term. This is the middle term, that is only one middle term, that is n by 2 plus 1th term. Okay, or for this we can write another result is t of n by 2 plus 1 is equals to nc n by 2 into x to the power n by 2 into y to the power n by 2. Okay, so we are finding the general middle term. You can use this result. Okay, when next, when n is odd, when n is odd, there are two middle terms. First one is n plus 1 upon 2th and another one is n plus 3 upon 2th term, or terms you can say. See here, when n is odd, you will get two middle terms. Now you might be got confused. Okay, sir, you said that when n is in the one of the example I told you. Okay, when n is odd, I got 1 as the middle term, and when n is even, we got two middle terms. But if you observe here, when n is even, we are getting one middle term. Why it's so? Why? Because see, in this expansion, x plus y to the power n, x plus y to the power n. Okay, when you expand this, okay, suppose this n is odd, this n is odd. Okay, suppose n is 3, n is 5, n is 7. When that n is odd power, okay, you will get one extra into that. One extra into that means what? Suppose here n is 3, then here number of terms are 4. Number of terms are 4, means it becomes even or no? It becomes how much? Even, correct? Similarly, when in this x plus y to the power n, when this power is even, when power is even, again in the expansion you will get one more extra term. Okay, now suppose power is 4, it is even, then number of terms in the expansion is 5. 5 becomes what? Odd. So what I am telling is, when the power is odd, okay, number of terms are even. Even means what? Two middle terms. When power is even, number of terms are odd, it means what? One middle term. Okay, see here, n is even, but in the expansion you will get how many? Odd number of terms. So therefore it is only one middle term. When here n is odd but number of terms are even, so therefore here you are getting how many? Two middle terms. So get it clear. So whenever the power is n, you will get one more extra in that, in the expansion. If the power is 3, in the expansion you will get 4 terms. If the power is 4, in the expansion you will get 5 terms. This is the difference. Okay. And for this general term, for this is t n plus 1 upon 2, n plus 1 upon 2 can be written as, see here, that is n c n minus 1 upon 2 into x to the power n plus 1 upon 2 into y to the power n minus 1 upon 2. This is one result. And another result for another middle term, t n plus 3 upon 2 can be written as nc n plus 1 upon 2 into x to the power n minus 1 upon 2 into y to the power n plus 1 upon 2. Okay. See the difference between this middle term and this middle term. Okay. When you are finding for first middle term, it is n c n minus 1 by 2 x to the power n plus 1 by 2 y to the power n minus 1 by 2. But when you are finding the middle term for second middle term, it is what? N c n plus 1 by 2. Here it was minus, there it is plus. Here it is plus, there it is minus. Here it is minus, there it is plus. See, there is a difference of sign. Okay. So note this result here. Next now, greatest term. Greatest term and greatest coefficient. Greatest term and greatest coefficient. Okay. So what is this greatest term and greatest coefficient is? So first we will study about greatest term. Okay. So if TR and TR plus 1 be the expansion, or you can say be the rth and r plus 1th terms in the expansion, of 1 plus x to the power n. Okay. So this tr and tr plus 1 be the rth and r plus 1th term in the expansion of 1 plus x to the power n, then we have the result tr plus 1 upon tr is equals to ncr into x to the power r divided by ncr minus 1 into x to the power r minus 1. Okay. And when you simplify this, you will get n minus r plus 1 divided by r into x. So you have to remember this result. Okay. And see, in this tr plus 1 upon tr plus 1 upon tr, see, always this tr plus 1 is greater than or equals to tr plus 1 is greater than or equals to tr. Otherwise you can write this as tr plus 1 upon tr is equals to what? greater than or equals to 1, greater than or equals to 1. So what is TR plus 1 upon TR? This is the result. Okay, so that is n minus r plus 1 upon r into x is greater than or equals to 1. Now this result, when you simplify for r, so r is less than equals to okay, n plus 1 upon 1 plus x into x, okay, or this r I am going to replace with m. So r is equals to m, I will take it. So m is equals to modulus of x into n plus 1 upon 1 plus x. Okay, so this is the result you have to remember. So whenever you are finding the greatest term, okay, so for that greatest term, condition is what? TR plus 1 upon TR will be what? N minus r plus 1 upon r into x. And you have to remember one more thing, always that TR plus 1 is greater than equals to TR. And suppose if you are finding for r, then r is what here? N plus 1 upon 1 plus x into x. Or suppose if that r I replaced with m, then I got this result. Okay, so this is for greatest term. Okay, now I will see greatest coefficient. What we'll see now? Greatest coefficient. Okay, see here. So in this greatest coefficient, see here, if n is even, then greatest coefficient is NC n by 2. Okay, if n is odd, then greatest coefficient is NC n plus 1 by 2 and NC n plus 3 by 2. Okay, so when if n is even, the greatest coefficient is what? NC n by 2. If n is odd, then the greatest coefficient is what? NC n plus 1 by 2 and NC n plus 3 by 2. Okay, this is another result of greatest coefficient. Next, we will see the properties of binomial coefficients. So what are those properties? See here. First property, okay, the sum of binomial coefficients, I will write in short, binomial coefficients in the expansion of x plus y, 1 plus x to the power n is 2 to the power n. Okay, sum of binomial coefficient in the 1 plus x to the power n is what? 2 to the power n. Second one, sum of coefficient of odd terms in the expansion of 1 plus x to the power n is equal to the sum of coefficient of even terms is 2 to the power n minus 1. Okay, sum of coefficient of odd terms in the expansion of 1 plus x to the power n is equal to the sum of coefficient of even terms in the expansion of 1 plus x to the power n is 2 to the power n minus 1. Okay. Third property, sum of product of coefficient in the expansion is 2n c n plus r, 2n c n plus r. Okay. Fourth property, 1c1 plus 2c2 plus 3c3 plus so on plus ncn will be written as n into 2 to the power n minus 1. Fifth one, 1c1 minus 2c2 plus 3c3 minus so on, which is always equals to 0, means 1c1, 2c2, 3c3, and if it is having alternative signs, then its value is 0, and if they all are positive, then answer is n into 2 to the power n minus 1. Okay. Sixth property, 1c0 plus 2c1 plus 3c2 plus so on plus n plus 1 cn, which is equals to n plus 2 into 2 to the power n minus 1, 2 to the power n minus 1. Okay. So these are some properties of binomial expansion you have to remember. So these are useful while simplifying the problems. Okay. Now see, one more thing I will tell you. So this 1c1 plus 2c2 plus 3c3. Okay. In the exam, sometimes they may give like this also, c1 plus c2 plus c3. Okay. Here n is not given. If n is not given, means it is not wrong. It can be written this or this, meaning is same. So in the examination they may give like this to you people, but this same as what? This only. This is same as what? This only. Okay. So don't get confused. Fine. Next, now we'll see some important expansions. Those are useful to simplify the problems again. So what are those important expansions? In that first expansion, 1 plus x to the power n, okay, it can be expanded as 1 plus nx plus n into n minus 1 upon 2 factorial into x square plus so on plus n into n minus 1 n minus 2 divided by r factorial, actually it is so on up to n minus r plus 1, n minus r plus 1 into x to the power r plus so on. Okay. So this is one important expansion I have given. You have to remember this. Okay. Suppose now if you are writing this for 1 minus x to the power n, 1 minus x to the power n, then what the expansion you will get is 1 minus nx plus n into n minus 1 into x square divided by 2 factorial minus so on plus n into n minus 1 n minus 2 so on n minus r plus 1 divided by r factorial into minus x to the power r plus so on. This is the difference. When it is 1 plus x and when it is 1 minus x, there is a change in the sign. Here it is plus, here it is minus. Next, here it is x to the power r, here it is minus x to the power r. Okay. Next, third expansion, 1 plus x to the power minus 1. It can be expanded as 1 minus x plus x square minus x cube plus so on up to infinity. Fourth, 1 minus x to the power minus 1. See, 1 plus x to the power minus 1 is this. Now 1 minus x to the power minus 1 can be written as 1 plus x square plus x cube plus so on up to infinity. Okay. After that, another fifth one, 1 plus x to the power minus 2. Then it can be expanded as 1 minus 2x plus 3x square minus 4x cube plus so on up to infinity. Sixth result, 1 minus x to the power minus 2 is equals to, same thing you will get but all are positive, up to infinity. Seventh one, 1 plus x to the power minus 3 can be written as 1 minus 3x plus 6x square plus 1 minus 3x plus 6x square minus so on up to what? Infinity. Okay. So these are some important expansions of binomial. Okay. So these results you have to remember. Okay. So here we have done with our theory part of this binomial. Okay. Now we have to simplify the MCQs. Okay, based on this results. Okay. So you please note it down all the results and once again you go through it. Okay. Okay, let us go with the MCQs. Okay, so this is the question here. Okay, so might be question is not clear to you people, then I'll write the question. What is the question here? Root 2 plus 1 to the power 6 minus root 2 minus 1 to the power 6 is equal to options are 101, 70 root 2, 140 root 2, option D 120 root 2. Okay. See then how you are going to simplify this. Here you have to make use of the binomial expansion. Okay. See here root 2 plus 1 to the power 6 minus root 2 minus 1 to the power 6. Okay. Now how you are going to simplify this? Okay. See here, I'll tell you one result, x plus a to the power n minus x minus a to the power n. Now you know both the expansions, okay. So this expansions, when you write it, see I'll show you first simple. If it is x plus a to the power n, what you write? nc0 x to the power n plus nc1 x to the power n minus 1 into a. Actually there are up to n terms, but I'm just showing you two terms here. If I expand x minus a to the power n, it is what I can say, nc0 x to the power n minus nc1 x to the power n minus 1 into a. By just taking the two terms, I am showing you the difference, what you will get. When you do the subtraction, what you are doing here? Subtraction. So when we do the subtraction of this, okay, what will happen? Sign changes. This positive will become negative. Negative will become positive. So this will get cancelled. So this is 2 times. So therefore this is 2 times nc1 x to the power n minus 1 into a. Getting my point? Means some of the terms will get cancelled and we left with one other terms. So if you write these terms for up to n terms, if you write this up to for n terms, then what result you will get? I'll tell you now. So you will have the result is what? So which is equals to 2 into nc1 x to the power n into a plus nc3 I think here it is n, okay, nc3 x to the power n minus 3 into a cube plus nc5 x to the power n minus 5 into a to the power 5 plus so on, okay. So this is the result when you subtract this, that is 2 times this. Now come to the problem. What is the problem? Therefore root 2 plus 1 to the power 6 minus root 2 minus 1 to the power 6. See, same, this one and this one both are same. X place is taken by root 2, a place is taken by 1, okay. Then what will happen? See, so 2 into just go on putting the values, 6c1 root 2 to the power 6 into a is 1, okay, plus 6c3 root 2 to the power n minus 3, okay. So n is 6 here, 6 minus 3 is 3 into 1 cube plus 6c5 root 2 to the power 6 minus 5 is 1 into 8, sorry, a means what? 1 here, 1 to the power 5, okay. And last term plus I think we'll get which one? 6c7, but that is not required because 6c7 term you are not going to get it because power is up towards 6, so hardly you will get these 3 terms in that, okay. Now you have to simplify this. 2 into 6c1 is 6. Now root 2 can be written as what we have here, root 2 to the power, some mistake I have done, okay, here it is n minus 1, here it is n minus 1, so then 6 minus 1 is how much? 5. So root 2 to the power 5 can be written as into 4 root 2, this can be written as 4 root 2 plus 6c3. When you simplify, you will get the answer is 20, and root 2 to the power 3 can be written as 2 root 2 plus 6. Simplify and see, okay. Next, 2 into 6 into 4, 24 root 2 plus 40 root 2 plus 6 root 2. So how much it is? 2 into, see, root 2, but how many times? 24 plus 6, 30, 30 plus 40, how much? 70 root 2, but outside 2 is there, 2 is going to multiply, 2 into 70, 140 root 2. So which option? Option C is correct. Option C is correct in this, okay. So see, just to get simplify that, we have done so much simplification. So now you have to remember this, when it is x plus a to the power n minus x minus a to the power n, result is what? 2 times nc1, nc3, nc5 you are getting which numbers? Odd numbers. Now suppose this you understood now, right? This all of you understood. Now see one more result I will give you now. If suppose if you are having x plus a to the power n plus x minus a to the power n. When it is minus, I got odd. When it is plus, means you will get what? Only even numbers. Means what? nc2 x to the power n minus 2 into a square plus nc4 x to the power n minus 4 into a to the power 4 plus so on. Means here we are getting nc2, nc4, nc6, nc8 and so on. Even you will get it. Okay. So just remember these two results. Okay. Next question here. Next question. Again might be this question is not clearly visible. I'll write it here. See. X to the power 5 plus 10 x to the power 4 into a plus 40 x cube into a square plus 80 x square into a cube plus 80 x into a to the power 4 plus 32 a to the power 5 which is equals to so this expansion is given. So this expansion is belongs to which option? Is belongs to which option here? So option A, x plus a to the power 3. Option B, 3x plus a to the power 3. Option C, x plus 2a to the power 5. Option D, x plus 2a to the power 3. So these are the, okay, here in the option B power is 5. Means after expanding which term you will get this expansion, that you have to check it, okay. So I think all are positive only, in between sign is plus only. Let us see binomial theorem. What is x plus a to the power n? What is that expansion? nc0 x to the power n plus nc1 x to the power n minus 1 into a plus nc2 x to the power n minus 2 into a square plus so on plus ncn a to the power n. So this is the expansion. Now just check it now by putting this, okay. Suppose if I take the first one, see nc0 value is 1 only, nc0 value is 1 here, but when I put x to the power n, here x to the power n is how much? 5, but if here n is how much? 3, so therefore this option is not possible. Even here also the power is 3, D option is also not possible. Then there is a choice between C and B, powers are 5. So if I take option B, what is the power? 5, so it is x to the power 5 plus nc1, n is 5, 5c1 is 5 into x to the power 5 minus 1 is 4 into a is how much here? Sorry, x is 3, no, x is 3x here, x is 3x, so 3x to the power 4 into a is how much? A only. Now see, x to the power 5 I got it, no doubt, but what about this one? Okay, so what will happen here? If I take 5 into 3 to the power 4 is 81 into x to the power 4 into a. So this will, if you multiply, 5 ones are 5, 5 8s are 44, not 5. But 4 not 5 is not there here. Okay, so option B is not possible only. So option C is left. Option C is left. Then 3 options are not correct, means option C should be correct. But see justification for that. X plus 2a to the power 5, right? NC0 is 1. X to the power 5 plus NC1. 5C1 is 5. Okay. X to the power n minus 1. What is x here? X only. So x to the power n minus 1. N is 5. 5 minus 1 is 4 into a. But a is what here? 2a. If I multiply this, 5 2s are 10. This is x to the power 4 into a. Check it. 10x to the power 4. That second term you are getting or no? Okay. So therefore, option C is correct. Option C is correct here. Okay. Okay, next example. Okay, I think the fonts got very less, but I'll write the question. The formulae a plus b to the power n. I'll write that question. A plus b to the power m, not n, m is equals to a to the power m plus m into a to the power m minus 1 into b plus m into m minus 1 upon 1 into 2 into a to the power m, b to the power m plus so on holds when, sorry, this is m minus 2, let me correct it, m minus 2 and this is m, sorry, this is 2. Fonts are so much less, so it's not visible clearly. Okay, see what is the question is, the formulae a plus b to the power m is equals to a to the power m plus m into a to the power m minus 1 into b plus m into m minus 1 divided by 1 into 2 into a to the power m minus 2 b square plus so on. So this expansion holds when the options are, I think options are visible. First option is b is less than a. Second option a is greater than b. Third option modulus of a less than modulus of b. Option D modulus of b less than modulus of a. So these are the 4 options. Among these 4 options, which option is going to be correct? A, B, C and D. Okay. Now see what we have, the expression a plus b to the power m. This expression we are having. Okay. Now this expression can be written as this, we can written as, I'll take out a to the power m is common. In this actually a is common, but it takes the power and it will come outside. So a to the power m is common. Then what is left? 1 plus b by a to the power m. 1 plus b by a to the power m. See, keep in mind, whenever it is x plus y to the power n, in this always, okay, in this always x is greater than y. X is greater than y, or I can say y is less than x. Y is less than x. Okay, remember this. X plus y to the power n, in this x is greater than y, or I can say y is less than x. So here also see, this is x, this is y. So therefore what? b by a is less than 1. b by a is less than 1. But here it is modulus n I'll take, modulus n I'll take, because it should be positive. Okay, now so this can be done as what? Modulus of b upon modulus of a less than 1, less than 1. Then this modulus of b, okay, this modulus of a transfer here, it will multiply, so it is less than modulus of a. So modulus of b is less than modulus of a. So option D is correct. Option D is correct here. Okay. So here you have to take the modulus. Therefore modulus means what? When you simplify that, option D is going to be correct. So which concept I used? This, in that x plus y to the power n expansion. Okay. X is always greater than y, or can say y is less than x. Yes, see, next the question number 4. Okay, so what it is given, question number 4, the total number of terms in the expansion of, I'll write that, x plus a to the power 100 plus x minus a to the power 100 after simplification will be, options are 202, option B 51, option C 50, and option D none of the above. Okay, so what they have asked, the total number of terms present in the expansion of this result, x plus a to the power 100 plus x minus a to the power 100. Okay, so how you are going to find this number of terms which is present in this expansion? See, in the first question itself, I had given a result. What is that result? If you remember, x plus a to the power n plus x minus a to the power n. Okay, so this result I had given to you people. Okay, and what was that result? What was that result? Yes, okay, that is 2 times. That is what? 2 times. Okay, nc0 x to the power n plus nc2 x to the power n minus 2 into a square plus so on. Correct? This result was given to you. Okay. Then here, okay, what we can do now? So we have to find the number of terms. Okay. So therefore this 2 you transfer here. So 1 by 2 into x plus a to the power n plus, okay, here it is 100 plus x minus a to the power 100. Okay. So which is equals to, what will get the expansion? 100c0 x to the power n, that is x to the power how much? 100, x to the power 100, 0, no, it is 100c0 x to the power 100 into a is how much? A itself plus 100c2 x to the power 100 minus 2 is 98 into a square plus so on. Okay, now okay, see, in this expansion now power is 100. See, when x plus a to the power n, then how many number of terms? N plus 1 terms are there extra. Whatever the power is there, in that one more extra term always you will get it. Now here power is how much? 100, means number of terms will be how much? 101. If the power is 100, then how many terms will get in the expansion? 101. Okay. Then 101. Then which option is going to be correct in this? See now. See here. Odd and even. So when you expand this, you will get 101 terms. In that 101 terms, how many you will get even and how many you will get odd? So it's very clear. See, in this you will get even is 51 terms and odd is 50 terms. When you count it, you will get even is 51, odd is 50. Okay, then I am going to say that, so therefore number of terms present in this expansion is 51. I have chosen only even numbers. Why? See here, when you add this both, which expansion you are getting here? 2 into NC0, NC2, NC4, NC6, NC8, you are getting only even. Odd are deleted, odd are deleted. So therefore odd you should not consider. So what is left then? Only even terms are left, and those are how many? 51 even terms are there. So therefore option B is correct in this. Option B is correct in this. Okay. So here I have done with some 4 questions now. Okay. Remaining MCQs I will solve into the next class. Okay. But for that you please revise those theory class results, so it will help you to simplify the next problems. Okay. So we'll stop here. The remaining we'll see into the next class. Okay. Yes. Thank you.